Hey, Sean here with SpeedQBview.com. Let's talk about how to solve a 4x4. Now this is going to be a pretty basic method going over simple ways with very few new techniques or algorithms. So the three things we need to know is how to make the 2x2 centers, then pair up the pieces that make the edges, and then finally solve it like a 3x3, and where we might come across what is known as parity errors. Those are things that cannot normally happen on a 3x3 and are caused by edges being paired up possibly backwards and need to be moved around. So obviously you need to know how to solve a 3x3 to do this. Now this will not prevent you from learning a faster method later, and most of what we will be doing is basically the framework for more advanced methods like YAO. So on to making centers. Most of this should be pretty intuitive. The biggest thing when you get towards the final centers is that if you want to move a piece into place, when you do an R or L move, then turn the U face, you need to do the same reverse R or L move to prevent any other centers from being messed up. Also, you need to know how the centers are set up on a 3x3 with the opposite colors like blue and green, but also I remember that red, white, and blue move clockwise around one of the corners. Now once you have all the centers set up, we need to pair edges. There are two of the same edges for each set of colors. All we do to pair them is use what I will call the edge flipping algorithm, which is RU R prime, F R prime, F prime. That will flip the edge on the front right. Now this cannot be used to flip an edge on a solved cube because it messes up other things around the cube. Now what we will do is put the same edge piece on the front face on the top of the pairs, both on the left and right of each other. You move the top two layers over, edge flipping algorithm, and then move the top two layers back. Now you can see right here on the right that those two edge pieces are now paired. Then you do the same thing for another two of the pieces. You'll be able to do this to solve all 12 edges. Moving the pieces into place can sometimes be difficult at first, but in time, manipulating the cube becomes easier. Once we have finished the edges, we can just solve it like 3x3. When we get to the last layer is when we come across the parity errors. First, we have an OLL parity. The OLL parity is basically where two of the same colored edges need to switch places. The algorithm that I use is a bit different than some of the speed solvers use, but it's still not many moves. I feel easier to remember and can be used on a 5x5 and larger to flip edges around. The algorithm is small r prime U2, small l F2, small l prime F2, small r2 U2, small r U2, small r prime U2, F2, small r2, F2. Once that is fixed, you can do your normal OLL and then PLL. Now if you come across a PLL parity, it's where you need to switch two edges. Now switching just two edges is not possible on a 3x3 without moving corners as well. The algorithm swaps these two pieces on the front and back. So overall, you just need to know the two parity algorithms, as well as the edge flipping one, which can be useful in 3x3 as well during the F2L stage. Thank you for watching. Please leave your thoughts and questions in the comment section below. Hit like and subscribe for more content like this in the future, and as always, stop by SpeedQBview.com for more news and reviews.